As its name suggests, a multi-valued subquery may return more than one result in the form of a single column set. A multi-valued subquery is well suited to return results to the in predicate, and if any value in the subquery result matches the in predicate expression, the predicate returns true. In some cases, the database engine will interpret a subquery as a join and execute it accordingly, so you need to test for both to see which one performs better. In this example, the query returns information about orders placed by customers in Mexico. The first query uses the in predicate along with the subquery, and the second query uses a join. Let's execute both of these queries and see what the results will look like. Let's open a new query and paste the query with the in predicate. Let's click on Execute, and it will display all the orders placed by customers in Mexico. Let's just execute the inner query by itself and see what the results will look like. Let's take these customer IDs, copy them. Let's delete this subquery and paste the customer IDs directly in the subquery. Let's execute it, and it will return the same results. Let's look at the query execution plan by going to the query and clicking on Display Estimated Execution Plan. Now let's change the query back to what it was earlier. Click on Ctrl Z, and it will go back to the query the way it was before. Now click on Execute, and now let's look at the query execution plan again. And you will see that SQL Server interpreted it as an inner join. You can learn more about the execution plans and the internals of SQL Server in a different course. But once you determine which query is performing better, you can either use a subquery or a join to get the results you require. So, in this lesson, you've learned how to use scalar subqueries and multivalued subqueries. In the next lesson, you'll learn how to write correlated subqueries. In the previous lesson, you learned how to write self-contained subqueries in which the inner query is independent of the outer query, executes once, and returns its results to the outer query. Microsoft SQL Server also supports correlated subqueries in which the inner query receives input from the outer query and conceptually executes once per row in the outer query. In this lesson, you'll learn how to write correlated subqueries as well as rewrite subtypes of correlated subqueries as joins for performance or logical efficiency. Let's first see what correlated subqueries are. Like self-contained subqueries, correlated subqueries are select statements nested within an outer query. However, unlike self-contained subqueries, correlated subqueries depend on the outer query to pass values into the subquery as a parameter. And the correlated subqueries cannot be executed separately from the outer query, which complicates testing and debugging. Unlike self-contained subqueries which are processed once, correlated subqueries will run multiple times. Logically, the outer query runs first, and for each row written by the outer query, the inner query is processed. And just like the self-contained subqueries, correlated subqueries can return scalar or multiple values. Let's take a quick look at this example. This query uses a correlated subquery to return the orders with the latest order date for each of the employees. The subquery accepts an input value from the outer query, in this case, the employee ID from O1, and uses it in the where clause and then returns a scalar value to the outer query. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw and click on Execute. And as you can see, some of the employee IDs are repeated because they're associated with multiple orders on the latest order date. Let's take a closer look at this query and trace the role of each clause. This select clause contains the columns returned by the outer query. The from clause contains the source tables for the outer query. The where clause contains the predicate used to evaluate the outer rows against the result of the inner query. And this select clause contains the column returned by the inner query, and the aggregate function max is used to return a scalar value. The from clause in the inner query contains the source tables for the inner query, and the where clause in the inner query contains the correlation of the employee ID from the outer query to the employee ID in the inner query. This value will be supplied for each row in the outer query, and the inner query is processed for each of those rows. And the order by clause is used to sort the results of the outer query. Now let's try to execute the inner query by itself and see if it will return any results. Let's click on Execute, and it returns an error because the inner query is dependent on the employee IDs from the outer query. Now let's see how to use a join to write the same query. Let's do select order ID, employee ID, and the order date from sales.orders table as O1, and let's use the table alias for all the columns to avoid confusion. And then join sales orders table as O2 on O1.employeeID equals O2.employeeID. Now add the group by clause to group by all the columns in the select clause. Let's copy and paste them here. And let's use the having clause, having O1.orderDate equal to the maximum of O2.orderDate, and let's order by the same columns that we see in the group by clause. Let's execute this query. Click on Execute, and you'll see that the returning results have the employee IDs, their maximum order date, and all the orders that were placed on that order date. Let's change the order by clause to just use the employee ID and the order date in the join query. Now let's compare the results between the subquery and the join. Click on Execute, and as you can see, the results are exactly the same. Let's expand the result pane so that you can see the results of the join and the subquery. And as you can see, the results are exactly the same.